Great. Thank you for attending this session of Griffin's Cannabis Online Workshop. I want to do a shout out, a quick word of thanks to our sponsors, AgDia, Anderson Injectors, the team at Premier that gives us ProMix, Lalamond, Plastica Cretus, Verano 365, and BioLine AgroSciences. They've helped us make this the educational series that it has become. Our 5-part series connects with improving efficiency and profitability in cannabis cultivation. Our goal for today's webinar and the entire series is that you learn about innovations and strategies that you can implement immediately or in the near term that can move the needle for you and your team. Today's presentation is by Grodan's Senior Crop Specialist, Marielle Taft, and she'll be taking us through the steps and how to optimize irrigation strategies in Stonewall. Marielle is a great resource and has an excellent presentation. Unfortunately, our second presenter today, Randy Nestor with Anderson Injectors, is unable to present today. He had an unavoidable situation come up. We're looking at the possibility of doing a webinar down the road with Anderson Injectors. I'll try and keep everybody posted to see if that comes to be. Please feel free to enter chat into the chat pane. We'll try and get those answered during the session or at the end. With that, Marielle, the screen is yours.
Great. Thanks, Greg. I'm assuming everyone can see my screen at this point.
We can see your screen. It still has our sponsors on it.
Perfect. Okay. All right. I'll jump into the presentation now. So for 53 years now, Grodan has been pioneering strategies and techniques for highly efficient commercial vegetable and traditional floriculture production. For the last 10 years or so, we've begun transferring that traditional horticulture knowledge and experience to the cannabis industry to help growers understand the fundamentals of precision irrigation and position them for greater success with high-tech Stonewall products. While we know that the cannabis genus requires different inputs and growing conditions than many of the traditional CEA and high-wire vegetable crops we've worked with in the past, we've been really thrilled to help growers worldwide understand some of the most important universal concepts of substrate management and energy balance that apply across all crop types. So in addition to the actual Stonewall growing media that Grodan manufactures, we also service our vegetable, floriculture, and cannabis markets with technical advice from experienced and dedicated crop consultants. We offer tools such as root zone sensors and climate sensors that enable growers to adopt precision growing strategies. And we offer some software platforms that transform the raw data from our substrate and climate sensors into more actionable insights relating to the water, fertilizer, and energy balance of your crops. In case anyone needs a refresher, when I refer to blocks and slabs and other Stonewall substrates during the presentation, this is just a brief overview of some of the substrate products that Grodan makes for the cannabis market. The catalog includes a pretty wide assortment of growing blocks, which are pictured here with their respective sizes and volumes, as well as pre-cut slabs and uncut slabs, which are pictured here. And many of the sizes and assortments of products are produced in both the Pargo line and the improved technology. Okay, so diving into precision growing. When we talk about precision growing, we talk about crop optimization a lot. We talk about high-tech irrigation, and all of those words can start to sound fairly jargony, I think, if we don't dive into the meaning of them. So here's a quick definition of precision growing. And when we use all of these terms, what we're really talking about is a holistic precision growing mindset, not a momentary action. So simply put, precision growing means growing more with less fertilizer, less water, less labor, less energy, and ideally fewer chemical inputs. We're shooting always for maximum outputs via minimum inputs. And most growers who adopt this kind of mindset and methodology quickly realize things like increased yield, maximum potency, and of extreme importance, especially in our medical markets, a highly consistent product. And then, perhaps of greatest importance, especially in mature markets, all of these efficiency measures, when combined, typically result in a dramatic decrease in the total cost per gram to produce, thus increasing profitability and lowering the environmental impact by reducing water and nutrient consumption and avoiding unnecessary runoff and eutrophication of water bodies. Okay, so crop steering, which is the buzzword of the last few years. A quick definition here. Crop steering is just the method by which we adjust environmental and root zone conditions to steer the plant's energetic expenditure towards the type of growth that we want. So vegetative and generative steering stimuli can be deployed at every single growth stage to keep the plants in balance and maximize their performance throughout the life cycle. So when we're crop steering, what can we leverage? Generally, the inputs we manipulate the most fall into the categories of either climate, root zone, or genetics. I won't go into genetics too much here, but I have a shorthand list of some of the qualities that we play with on the genetic side. But within the categories of root zone management and climate management, there are some really important parameters that we should always be paying attention to, understanding their effects, their correlative and causal relationships, and manipulating them proactively to get the outcomes we desire. Proactively being the operative word here. Among the most important parameters we manipulate in the root zone are substrate water content, the pore water EC, the overnight dryback, and the inter-irrigation dryback. There's a handful of others listed as well that are relatively important. And in the climate department, we're very concerned with adjusting ambient temperatures, relative humidities, vapor pressure deficits, carbon dioxide concentration, light intensity and spectral composition, and a few other parameters as well. Okay, so we leverage all of these tools we have at our disposal, and the question becomes, what do we get out of it? So when we do this, we can typically realize lower energy costs, more efficient use of labor, more precise application of everything really from water to fertilizer to light to supplemental CO2. And we can substantially reduce the environmental impact of our business activities while improving our bottom line through achieving consistent, high yielding, and high quality harvests. Okay, so approaching root zone management, I can't stress enough that there are certain qualities within substrates that make them more or less desirable for precision growing and crop steering applications. We have growers reach out all the time asking how they should navigate particular problems in stone wool versus cocoa versus maybe a peat mix they were growing in. And with every single question, the answer is really heavily dependent upon the substrate type and the substrate design. So the type, the height of the container, the fiber orientation, if it's stone wool, meaning vertical or horizontal fibers, the fiber diameter, the wetting agent and binder chemistry, the density, the particle size and particle heterogeneity. All of those qualities matter a lot and will dictate the irrigation strategy that needs to be deployed. And one of the most overlooked items is whether the substrate volume per plant and per square meter or square foot is appropriate to maintain control over the water content and EC of the substrate. So this is a little bit more on substrate technical design. There is definitely no one size fits all choice, and that's why we get so granular at Grodan about the differences between our particular substrates, because While they're all excellent, there really is an ideal specific choice out there for every facility and every particular plant production program. So some folks might benefit from more liters of substrate per square foot or square meter. Others might require less, and some facilities will be more suited to blocks on slabs, while others will do well in a single plant system with like an individual large block. But what remains consistent is that uniformity and consistency of the substrate is one of the most important qualities you can look at when you're evaluating growing media. So when I say uniformity, we're looking at, is the volume of substrate consistent from pot to pot? Is it actually 3 liters, or does one pot wind up with 4 and the other wind up with 2.5? Is the density consistent? Are the fibers all the same diameter if it's stone wool? How is the water and nutrient partitioned within the substrate? All of these factors have pretty dramatic implications on root and plant development. The more uniform the substrate, both from plant to plant and within each discrete block, slab, or pot, the less water will be required to manage the EC and nutrient balance within an irrigation zone. And this is just because generally we see that the higher the standard deviation between plants in water content and EC, the more water the grower has to apply in order to meet the needs of all the outliers. And so as the crop cycle continues, the discrepancies turn into pretty ingrained feedback loops that eventually override your ability to control the crop uniformly. Density and capillarity and absorption also become really important substrate qualities when considering water efficiency and managing optimal growth. So density will impact the air and water porosity. It'll play an important role in how much plant available water the substrate can actually contain. And it may even also affect how much energy a plant has to exert to draw water out of the substrate. So while a highly dense substrate might offer a decent water holding capacity in some instances and have good resaturation capabilities after a dry down, it will take a lot of water and a higher flow rate to manage the EC and displace old fertilizer solution from the pores. Extremely high density substrates can also create a large proportion of micropores such that the air and water ratio can become undesirable. So for people suffering from poor root quality or vascular diseases like Pythium and Fusarium, or other diseases that reduce root vigor and root structure like hop latent viroid, very high density substrates may seem simple to manage, but often result in massive upticks in the required runoff and eventual decreases in root quality. Excessively dense substrates can also make it really challenging for growers to titrate down their nutrient solution as the crop's metabolism declines and plants approach senescence. So it can require huge amounts of water and runoff to reduce the substrate EC, which unfortunately can also inadvertently send the plants a very vegetative message at a time when the grower might really want to be focusing on ripening the crop. Then leaning on the other end of the spectrum, a substrate that's extremely low density and very free draining might allow the grower to refresh the nutrient balance easily and displace salt, but it will typically have poor resaturation capacity and less uniform nutrient distribution. So these are all really important properties to consider when selecting a growing medium. Other factors to consider include chemical availability of the substrate and its potential interaction with the applied fertilizer solution. So does it adsorb cations to the particle surfaces? Does it come with nutrients or ions that need to be leached? Those are important questions to ask. And in general, substrates that offer a good balance of all of these characteristics listed on this slide will allow growers to control and maneuver the conditions of the root zone responsibly, all while maintaining the highest degree of plant health and resilience. Okay, so getting started with stone wool substrate specifically, It's really important to go back to basics here. So whenever we get started diagnosing crop issues, some of the things we ask are related to the substrate volume per plant, the planting density, the substrate volume per square meter or square foot, the grower's intended vegetative time, and whether they plan to top their plants or not. We also look in on the drip emitter flow rate and whether the fertigation and irrigation infrastructure can support growers delivering the correct irrigation volumes or shot sizes. All those factors might seem really, really basic and foundational, but they're intrinsically connected and will really impact the grower's ability to steer the root zone to optimal conditions during each critical week of production. So a lot of times, growers will report secondary and tertiary crop symptoms and issues that are real, no doubt, but a large percentage of the time, the issues are actually just later stage manifestations of what's actually a primary improper root zone management issue. So a quick note here on substrate calculations. I'm assuming most folks here know how to calculate substrate volumes, but it's such an important foundational item that I thought I'd leave an example here in case anyone wants to refer to it. So for Grodan products, this is particularly simple as you're just calculating the volume of a rectangle in most instances. So really all we have to do is take the length times the width times the height of any given product. And I strongly encourage everybody to work in metric system values instead of imperial because, because the metric system values just work a lot better and make things significantly more simple. So basically, once we have the cubic centimeter volume of the product, we know it's the exact same as the milliliter volume, which is just 3 significant figures away from the volume in liters. So all we have to do is slide around decimal places to go from centimeters to milliliters to liters. So this is a lot trickier if we try to do it with, averaging inches or rounding inches up or down. So the example here, a Hugo block, which most folks are familiar with, is approximately 6 by 6 by 6 inches. The actual dimensions are 15 centimeters by 15 centimeters by 14.2. And so that block has a volume of 3,195 cubic centimeters or 3,195 milliliters or 3.195 liters. So that's the way we calculate volumes. We have charts of different product sizes with the centimeter values if you want to get really granular and specific. And if, substrates are stacked or used in a multi-block or a block and slab configuration, it's simply a matter of adding the total volumes together. Okay, the volume. We spend a lot of time on volume because it really matters. And I want to talk about what happens if we have too much and what happens if we have too little. So typically, if we transplant into too much substrate, the grower won't be compelled to irrigate frequently, which is one of the really important keys to initiating fast and vigorous vegetative development. In these scenarios, the root zone can remain excessively wet, drybacks can happen at an extremely low rate, and the grower is constantly at risk of overwatering when trying to adjust the substrate EC or the pore water EC. So if the grower has to displace most of the water held in the pore spaces with a lower or a higher EC solution, but the plant doesn't actually need any additional water, we often run into issues of overwatering. So too much substrate can really lead to slow vegetative development, a poor root system architecture, and stunted and weak plants. When the substrate is oversized for the plant, we can also see that stubborn higher fraction of water in whatever the substrate volume is that's being used can lead to conditions where the air porosity and the oxygen in the root zone is quite low. Then moving into the other extreme, if we have too little substrate, we run into a cascade of other issues. So generally a grower who doesn't have enough substrate per plant and or per square foot or square meter will have a hard time keeping up with the irrigation demand. So the dryback rates will be quite fast, and the frequency at which the water will need to be replenished in the substrate could have a very vegetative effect on the plant development during a time when generative steering might potentially be called for. So we can also see, in conjunction with those dynamics, really erratic and excessive drybacks that may come with EC spikes, salt concentration and precipitation, and overall osmotic stress. Sometimes we see also considerable pH fluctuations in the root zone in these scenarios in conjunction with fertilizer uptake. And roots can also, essentially be running out of physical pore space in these scenarios to occupy. So they may begin physically compressing the fibers, leading to a reduction in overall water holding capacity. We can also see that crops might be exerting like an inordinate amount of energy just to draw water from the substrate at low water contents, rather than utilizing that energy for flower production and growth and generation of secondary metabolites. And of course, last but definitely not least, the substrate is also important for providing physical support to a crop. So plants can topple over if they're not supported when we find ourselves in scenarios where we don't have enough substrate. So those are, the extreme ends of the spectrum, and the question becomes, what's the ideal range? And we look at this generally on a more granular level as both volume per plant and volume per square meter or square foot. But generally, a nice range for most cannabis facilities is roughly 18 to 26 liters per square meter. So where we fall within that range can depend on a variety of factors, including the vegetative time, whether the grower is in a single or a double or even like a triple tiered vertical racking system, whether they intend to top their plants to extend the vegetative time or decrease the plant density, their intended number of plants per square foot, and the overall genetics and plant structure. So all of those factors combined will generally push us either on the lower or higher end of that spectrum. Okay, another really foundational item, but I wanted to drop this in here, is about how we calculate shot sizes. So once we have all of the substrate elements in their ideal ranges, how do we know how much to water? So this is really important when, we get into vegetative and generative crop steering. And it's worth giving it a moment to calculate in case anyone is missing this information. So the shot size itself simply means the volume of water that's going to be delivered to each plant in any given discrete irrigation event. So in most scenarios, it'll be advantageous to give irrigation events anywhere from 1 to 6% of the total substrate volume you're using. There are some scenarios in which slightly larger fractions might be called for, but 1 to 6% is a good range. So all you need to do to calculate the volume in milliliters, and then all you need to do is actually calculate the volume in milliliters and take the percentage. So from our previous example, we did a Hugo block that was 3.195 liters or 3,195 milliliters. So taking 3% of that 3,195 milliliters gives us a shot size of about 96 milliliters, and a 6% shot size would be about 192 milliliters. So it's really as simple as that. And same with the volumes. If you're using multiple substrates or you're putting a block on a slab or a block on a block, you'll just use the cumulative volume of all the substrates that you have stacked up, and then you'll take the percentage of that cumulative volume. So once we have all those basics in place and we know we've selected the correct volume and we have the correct configuration of substrate, we really need real-time data for both climate and root zone to drive good decision making. So In addition to a quality substrate that we know is steerable and responsive, ideally you want to be able to centrally monitor all of your root zone and climate parameters so you can identify trends and interactions over short and long-term periods. So through measuring and monitoring root zone water content and EC and substrate temperature, we can figure out exactly how much to water, how frequently to water, what drip EC to water with, and how much leachate to target every single day. We can avoid overwatering and wasting fertilizer. We can avoid underwatering and causing excess drought stress or cumulative elemental imbalances. And we can adjust our start and stop times to avoid root pressure and minimize risk of things like mold and fungus. Most importantly, we can walk up to the edge of a lot of these ideal water content and EC thresholds intentionally and proactively without exceeding them, pushing plants to their physical and chemical production limits, but not causing harm that hampers production. Okay, so from the root zone perspective, in addition to visualizing substrate water content, oh, sorry, I'm one slide ahead here. In the root zone area, in addition to visualizing water content and EC and temperature, I also strongly recommend collecting on-site data in the form of water gift per plant, EC gift per plant, and pH gift per plant at the emitter level. Taking those manual measurements once in a while in conjunction with measurements of the runoff fraction per plant, the runoff EC, and the runoff pH is a really good way to periodically make sure that you're actually delivering the volume, EC, and pH that you think you are, and to ensure that you're accurately applying water and fertilizer.
Marielle,
Yes.
I just want to jump in. A chat came in that's it's a really good question. If you were to maybe stay on this slide, I just want to set it up. We've got a wide range of cultivation growers on the call, large and small, and there could be someone here that's brand new to Grodan,
Sure.
and using this type of substrate. So if someone is in that situation, what would be a good starting point for substrate size for a grower that's new to Grodan? Like, so I'm interpreting this question as maybe they're using something else right now, and they're
Mm-hmm.
moving over to a Grodan product. They're growing cannabis. What is there a starting point, or is there a metric that you can use as a starting point?
Yeah, well, I think this question I'm guessing is kind of is um edging at the information displayed in this slide, which is really, this is a good starting point. So this 18 to 26 liters per square meter or 1.67 to 2.42 liters per square foot. So there's different ways to work into it, right? You can work backwards from saying, I know I want to grow this many plants per square foot. Or you
Mhm.
can work the other way and say, I know I should have this much substrate per square foot. So how many plants should I grow? This is where it really is a case by case basis, depending on how long this grower is potentially going to have their vegetative time take place, because that's going to dictate by and large, the final plant size, final plant height, and even the root volume that the grower is going to develop in the substrate. Really, really broadly and generally speaking, if it's someone coming off of a different substrate and just wanting to get started, a really simple way to get started is with a single plant system of something like a Hugo block, which is that 3.195 liters. So, it's similar to 1 to 1.5 gallons, or that's a little bit shorter, which would be a jumbo block, which is about 6 by 6 by 4 inches. But the important thing then is to look at the number of blocks that would be placed on a growing bench or a table, and to see if multiply basically the substrate volume per block times the number of blocks and see if you fall into that 18 to 26 liters per square meter or 1.67 to 2.42 liters per square foot. Does that make sense? So essentially you would take, as many blocks as you're going to use, multiply the individual block volume times that many blocks, and then divide it by the square footage of canopy that you have, and you'll see if you're in that general range.
I think that's the metric right there that answers that question. Where is a good starting point? And while we were talking, another question came in, and I think it's appropriate for this part of the presentation. So we have a grower that is currently using Hugo blocks for indoor production, currently running trials to determine which strains. Hang on just one second. Which strains perform better untopped versus topped? Could you please spend a little bit more time on topped versus untopped as it plays out in Rockwell?
Sure. Well, from a substrate perspective, the reason we're really asking about it is because I think a lot of times growers don't think about what's happening in the rhizosphere, and they're just focused on the visual observation of what's happening with the plant biomass above ground. So when we ask about topping versus not topping, that's our way of recognizing that if you are topping a plant to extend the vegetative time, for example, or to create a plant structure and architecture that is capable of basically spreading more laterally and covering more square feet, you will probably need a little bit more substrate under that plant, because while you may have taken off some of the above ground biomass, while you may not be growing a plant that seems quite as tall, or I don't know, quite as big, generally speaking, as if you let that plant grow up with apical dominance, what's happening underground or in the substrate is you're still building out a sizable root system architecture and root volume. And so it's almost like thinking about bonsaiing. Like you can top or shape a plant all day from above, but there is still going to be a substantial root system below that requires enough pore space, enough water holding capacity, and enough substrate to keep up with root zone conditions. So, genetics, that's one thing to evaluate for sure. And some plants will absolutely perform better when topped due to the structure they can achieve and the way that they can intercept photons and light energy. And some will do better without. But as it pertains to root zone management and substrate, the thing to consider is if you're topping and if you are extending your vegetative time through topping, don't be fooled into thinking that you can get away with a really low volume of substrate, because you still are building a root system across the entire time that you're in a vegetative growth stage, and even into the flowering stage. So that's where you might want to think about sitting on the higher end of that spectrum in terms of substrate volume per square meter. Whereas if you're not topping and if you're flipping your plants to flower relatively quickly, you might be on the middle or lower end of that spectrum. Hopefully that addresses the question. We're always, by the way, happy to go into this in more detail in one-on-one consults, and we've got a team of technical advisors that is happy to talk about more of this on a case-by-case basis if there are some questions that linger after this webinar. Should I keep going, Greg?
Yeah.
Okay.
And
cool.
Thank you for that, Marielle. I think
Yeah.
I think the tail end of that explanation really kind of nailed it. So thank you.
Great. Yeah, of course. Okay. So let's see, where were we? Okay, I talked about some of the other manual measurements that are worth taking in terms of runoff volume, runoff EC and pH, as well as the gift from the drip emitters to make sure that you're irrigating the volume and the EC and the pH that you want to be in, that you think you are. And so moving on to the environmental side, the big thing we need here is good longitudinal data on climate so that we can steer plant growth in an ideal direction, avoid losses to pathogenic microbial pressure, and run our equipment in the most energy efficient way possible. So we need to be able to visualize all of the climate parameters listed here to identify if there are any precipitous changes or spikes in conditions like relative humidity, temperature, vapor pressure deficit. And that's especially important during transitions from day to night, where those swings and spikes are fairly common. We want to be able to see if mechanical equipment is cycling on and off too often, if our dehumidifiers are fighting our humidifiers. We want to be able to see if our carbon dioxide is being supplied at a high enough concentration for our light intensity so that we can increase the net rate of photosynthesis. And indoor growing especially can be quite energy intensive. So it really behooves us to ensure we're running our HVAC equipment efficiently and thoughtfully. It's also important to have a system that collects and stores this data in association with specific batches or crop cycles. So you can compare it to previous crops' performances and correlate the data to your visual observations, your anecdotal observations, and then your empirical outcomes and your yield and potency records. As well as your things like A to C ratio, trim volumes, all of those other key performance metrics. Essentially, you need to be able to look back at all of your conditions and determine what went right, what went wrong. If you had a bumper crop 3 turns ago, you need to be able to pull up the root zone and climate data so that you can replicate it and yield on a consistent basis. And then on the flip side, if you sustain considerable losses to mold, for example, or develop powdery mildew early in your cycle, you need to be able to look back and identify the host of conditions that you sustained that may have made the establishment of mold or fungus optimal, for example. And then lastly, on this data element, I can't understate the importance of overlaying climate and root zone data and looking at them in tandem. So for many, many years, I think many of us were analyzing our climate data separately from our root zone data. And to be able to isolate things like a water content curve in conjunction with a VPD trend, for example, is tremendously helpful when you're trying to target appropriate transpiration rates. Perhaps your VPD was too low, causing reduced transpiration rates and elemental deficiencies of nutrients like calcium in the new growth. Maybe it was too high, driving water out of your plants too rapidly, so it depleted your substrate water content and made your EC skyrocket. Looking at all these measurable root zone and climate inputs and outputs together, this is how we put all of the elements of cultivation and all of the most essential photosynthetic inputs into balance. So a lot of people have major limiting factors that are hampering their growth rate and potential, and those will only become obvious once all of the data is visualized and analyzed in tandem. All of the elements we can control that determine the photosynthetic process and the development of secondary metabolites in plants should be in balance to achieve optimum production. So being able to look at all of our climate parameters alongside all of our substrate measurements gives us really important insight into what our plants require and how we can push them towards peak production. It's also really important to look back at this data to identify trends and thresholds by cultivar. So to know, okay, for this genetic, when my EC crosses this threshold for too many days, the pistils on my flowers start to turn prematurely, or the water uptake rate declines because the salinity is too high. Insights like this are really powerful, and they're not visible to us without data. So it's really important to understand that climate will drive root zone behavior, and in turn, root zone conditions can drive the observed climate to an extent. So having an understanding of the interplay between the two will help you avoid deploying strategies in a vacuum. It's really powerful to visualize, for example, that your increase in light intensity is having a direct impact on the amount of water removed from the substrate, or that your vapor pressure deficit being too high might require you to increase your irrigation frequency to avoid precipitous drybacks in your substrate. Or from the climate side, that, you know, your CO2 tanks running out could cause plant stomata to open extremely wide, triggering excess moisture loss to the environment and causing your relative humidity conditions to exceed your dehumidification capabilities. And those are all just examples of dynamics that we identify really regularly when we're able to overlay climate and substrate data and when it's readily accessible to us.
Marielle,
Yes.
is it pretty safe to say you can't do this, you can't grow this crop just by feel? I mean, you really need to dial in and have all the data points.
Yeah, I mean, I think it's safe to say that a lot of times if we're doing things by feel, when it goes well, it's luck. And it's hard to know how to repeat that lucky strike. You know, for years, I think most folks were putting their finger up in the air and seeing which way the wind was blowing and kind of deploying touch and feel strategies. But once you start operating at a large scale, have a lot of compliance metrics that need to be observed, have a lot of overhead, a lot of really thin margins for error, this becomes really, really difficult and really kind of dangerous to do without any real-time data. So yeah, I'd say that's correct in my opinion. Okay, and then last piece here was substrate sensors, just to get more granular on what are we actually doing with them. Most of you are probably familiar with root zone sensors to some degree, but in a nutshell, what we're doing is we're responding to changes in the root zone proactively. So we're not waiting for someone to go into a facility and pick up a pot and realize it's bone dry before we water. We're providing irrigation and fertigation cues that tell the plants where to focus their energy. And we're targeting really specific day and nighttime dynamics by adjusting the start time, the stop time, the shot size, the shot frequency. Like those are your primary inputs on the root zone side. Your inputs are the shot size, the shot frequency, the start time, the stop time, the drip EC, pH, and temperature. When we adjust those specific inputs, the primary outputs that we see through the data and the graphical information are changes to the overnight dryback, changes to our inter-irrigation dryback, changes to our substrate EC, and then the overall crop steering messaging we're sending the plants.
Marielle.
So, yeah.
Before you move off that slide, thanks. I think I know what they are, but if you could ID the two blocks stacked in the picture there.
Oh yeah. So this Steve, it's a little hard with the scale, but this is probably it's a uniblock on the bottom. And it looks like a 4-inch a GR10 on the top.
Okay.
Yeah.
Thank you.
Okay.
Yeah, we had a question.
Yeah, no problem.
Looking to identify that image.
Yeah, uniblock on bottom and pretty sure that's a 4x4x4 on top. Okay. So getting into the actual crop steering portion of things, one thing I've noticed for a really long time about cannabis producers is I think a bit more, it's more pronounced than with traditional ag growers, is that we tend to take things to extremes with cannabis. And we're super lucky because it's an extremely drought tolerant, salt tolerant, light tolerant crop. And I know we're often feeling like we're in a rush because our crop has a really short life cycle. But I always want growers to keep the idea of momentum in the front of their minds when approaching crop steering. So just because a plant might tolerate certain actions and not wilt or die doesn't mean that crop steering in total extremes won't cause a crop to lose momentum or production potential. So gradual and measured is the name of the game when crop steering. If people aren't familiar with it, I always like to describe crop steering as tilting a needle on a dashboard. So rarely are you flooring it 100% in one direction or the other for too long. You're just tipping the balances to encourage the type of growth you want. So this is a very simplified and generalized crop steering roadmap that works well as a starting point for most commercial cultivars. It's by no means a prescriptive recipe, and when the shifts and transitions are made for you will depend dramatically on the cultivars you're growing and the facility infrastructure you have at your disposal. That said, we have to start somewhere, and this is a great starting point from which to refine your strategies. So getting into the vegetative phase, this is such an important time for a cannabis plant. And the faster you can begin providing a vegetative stimulus to your plants, the more vigorously they'll develop ideal tissue to support heavy and potent flower loads. So in veg, we're focusing on generating large leaf area indices to intercept as much light energy as possible, strong and healthy root systems to keep up with the water and fertilizer demand, and strong and wide stems and vascular systems to facilitate optimal sap flow and structural support. The key from an irrigation perspective to vegetative steering is low volume, high frequency irrigation. That is one of the best ways to get plants active in the vegetative phase. I've listed some other parameters and climate cues here, and these are very generalized, but these are all inputs that will deliver the plants a relatively vegetative message in terms of their energy expenditure. Getting into flipping the crop and the first few weeks of generative steering. I've worked with growers for a really long time, and for many years, I think most of us thought that the only thing you could do to initiate flowering in a short day crop or a photoperiod crop was change the light cycle to 12-12, 12 hours on, 12 hours off. But in reality, when we build these high-tech, really expensive indoor and greenhouse facilities, what we're doing is giving ourselves a huge array of tools in our tool belt that we can use to strongly reinforce that photoperiod signaling, thereby asking the plants to shift their energetic expenditure away from vegetative tissue and into reproductive structures a lot more quickly. So why do we want to make that shift happen quickly? Primarily because, again, the cannabis plant has a pretty short crop cycle. And so the faster, more vigorously, and more emphatically we can message these plants to shift out of their vegetative state and get to setting up buds and flower structures, the more of this very short crop cycle we can spend swelling and bulking those flowers and building dry matter. So this is the point at which we tip the needle very generatively with most cultivars, by reducing the irrigation frequency and increasing the volume, targeting larger inter-irrigation drybacks during the day, and gradually targeting larger and larger overnight drybacks. Moving on to the middle part of the flowering phase, once plants have had a few weeks to shift their energy towards reproductive structures and the flower sites have fully emerged and pistils are elongated, it's beneficial to bring some vegetative balance back to the crop and reduce some of the drought and osmotic stress we've carefully and intentionally applied at the beginning of the flowering phase. So this doesn't mean that we tip the needle all the way back to the most vegetative climate and irrigation we can. It simply means that we're easing off the plants a bit in terms of salinity and drought stress so that the plants can maintain momentum and begin bulking the flower sites that they've developed. So we don't necessarily go back and try to recreate the conditions we had in the vegetative phase precisely. We just start to steer the crop towards a slightly wetter, slightly lower EC condition so that it's easier to move water and nutrients through the vascular system, and so that we don't hit any salinity thresholds that can be damaging to the root systems. And then getting towards the end of the cycle, in the final 2 to 2.5 weeks or so, it's beneficial to start giving the plant ripening cues. So this is done through a combination of applying generative stimuli in the root zone and giving climate cues that to some extent mimic the evolutionary history of this plant in many parts of the world, not in all parts of the world, but we're yet again tipping the needle back to a generative steering position. But we also have to be mindful that by this point, the crop's metabolic and fertilizer demand has usually gone down. So from a root zone perspective, while I definitely don't suggest performing a water flush on this crop, as I think it can do more harm than good in large scale commercial facilities, I do think it's really important to monitor the substrate EC in this phase, the substrate runoff, and then titrate down the fertilizer levels as the crop's metabolism slows, being careful in that process to not create large swings in osmotic pressure. And this is on that subject matter, a little bonus slide in recognition of the fact that a lot of growers find it difficult to encouraging ripening, especially under sole source supplemental lighting. And so all that said, sometimes generative root zone steering isn't quite enough on its own to encourage certain cultivars to ripen. And growers will sometimes call and say that they see a reemergence of white pistils and leafy vegetative matter towards the end of their crop cycle, which they want to avoid. And this is understandable that it happens where, it's essentially we have the female plants that we're growing are basically recognizing that they have not yet been pollinated and will use whatever energy is available to shoot out fresh, sticky white pistils in a last-ditch attempt to collect pollen. So in some cases, growers can see success by reducing some of the necessary inputs for growth and photosynthesis. So this can include things like reducing light intensity a little bit, not a lot, obviously, because we can miss out on growth if we do it too much. Reducing CO2 supply a little bit, titrating nitrogen supply especially, although keep in mind some nitrogen is needed for photosynthesis, and being very, very mindful to not over irrigate the crop towards the end of the cycle and create a vegetative effect. So this is, these are a few slides about a few other irrigation and rhizosphere insights that we can benefit from when we have the root zone data at our fingertips. So in this case, we're using all of this data as our primary mechanism for making decisions and deploying crop steering strategies, but there are just some clearly practical benefits to using root zone sensors that can act as an insurance plan for your facility. So here you'll see that several irrigation zones in a flowering room begin the morning resaturation events from the overnight low volumetric water contents of about like 30 to 35% range. But you can see where I've circled that one zone continues to see a drop in water content and a spike in EC in conjunction. And so in this case, what happened is the solenoid for this zone failed, it didn't open, and the grower was able to quickly catch and identify the problem before any plants were lost or before the substrate got to a point where it couldn't be rehydrated. For a more automated safety net, alerts can be really helpful to proactively notify the grower that root zone or climate conditions are out of ideal ranges. So in this case, the particular cultivar's water content was exceedingly low and the EC was getting quite high, and the grower had set thresholds at these points. So He received a text message alert and was able to intervene in time. And then this is one thing we deal with a lot that I thought was worth mentioning, which is we connect with growers who sometimes report issues with their water content declining day after day. And their response in, a totally understandable panic is often to apply even more water via longer and longer watering events. And they'll call and they'll say, I'm turning the taps on for 20 minutes, 30 minutes, and my water content keeps going down. And in many instances, when we have the root zone data accessible, we can identify that they may have been using either too large of a shot size or that their emitter flow rates were too high. So in the case of excessively large shot sizes, the capillarity of the media can be overpowered by gravity due to the mass of the water being applied all in one go. And so in that scenario, we can identify that issue and suggest the grower utilize and work with smaller shot sizes to encourage rehydration in the media. And then in the case of excessively high flow rates, we can find that premature drain channels can be caused to open at lower water contents, preventing growers from adequately rehydrating the blocks each day. So once we identify the pattern, it can be really easy to resaturate the blocks or slabs by reducing the shot size and increasing the frequency, or just correcting the flow rate issues. So overall, if we really want to use all of the tools at our disposal to push plant production to its maximum expression, the one thing we often lose is our margin for error. So growing under really high light intensity with high drip and high substrate ECs, aggressive drybacks, and overall just pushing the limits of photosynthesis and assimilate production means that we need to be on top of all of the conditions and take corrective action quickly if problems arise. And we need to really initiate each crop cycle with a proactive strategy and mindset. So from the root zone perspective, having the right combination of substrate that's both steerable and responsive, and leveraging the best data visualization tools to monitor the rhizosphere conditions will be pretty critical to success. So summing up, we really need real-time longitudinal root zone data to drive continuous improvement of outcomes. It allows us to develop customized and cultivar-specific crop steering strategies. It offers us a protection plan to prevent accidents and avoid sustained crop stress conditions. It allows us to understand the intrinsic connection between how climate drives plant activity and plant activity in turn drives climate. And it allows us to steer the crop's energy in an intentional and productive way during each phase of growth, all while ideally preventing waste on both the irrigation and energy side. And that's it for me. Are there any other lingering questions?
Yes, several questions have come in. Marielle, thank you. Let's try and get those answered. A power-packed presentation with just a ton of info. Let's see here. I've got one here, Marielle, that says, where's the ideal placement and what is the ideal depth for a half a gallon per hour drip stake? We are using 1 stake in veg and increasing to 2 stakes for flower.
So it depends on the manufacturer of drip stake, but I will go out on a ledge and assume it's Netafim drippers because they're so common. If not, feel free to get in touch with us after and let us know if it's a different manufacturer. But in most cases, the angled barb Netafim drip stakes work best if they're only inserted as far as they need to be to essentially not fall over or fly out of the blocks. There's other types of drippers, wedge drippers, and other brands where you want to situate them at a lower point. And that will usually, that information will come from the manufacturer. But with the most common Netafim stakes, if you've got those at the half gallon an hour flow rate, you really don't want to push them far into the substrate, because the further in you push them, that's usually where the water table will sit perched. As far as like positioning them horizontally, in most blocks, you want to have them on diagonal corners, and you want to have them halfway between the outer corner of the block and the plant stem. So you don't want to have them too close to the base of the plant. But especially with wide blocks, you also don't want to have them all the way out at the edges. So generally that middle position is ideal.
Okay, great.
But it's a great question, because we definitely see growers shoving angled barb drip stakes way far down into their substrates, and it creates issues with stratification of water along the vertical gradient.
Good. It sounds like we got to chat back. It sounds like that answered the question. Thanks. Another one came in, Marielle, about the starting size of the block selection. Do you know if it makes a difference on a plant started from clone versus seed?
Yeah, well, so the more well-rooted your cutting or your seedling is, the more poised you are to go into a bigger substrate. So if you're using a larger substrate to get started, you really want to make sure that you have good pin root coverage across the propagation plug, and that you have a healthy plant that's ready to root into a new substrate. Generally speaking, with seeds, because you're in most instances going to transplant them when they're overall smaller than a traditional ex vitro cutting, I would recommend going into a smaller volume if you can and if you have the wiggle room. Because yeah, you're typically, depending on at what stage, whether you're waiting for true leaves to appear or not, you're still putting in a plant that overall is a lot smaller when you go from seed. So yeah, smaller block, potentially. Like, I think for transplanting seedlings, that any of the 4-inch blocks are really excellent. My preference is the 4x4x3 or 4x4x2.5, but even the 4x4x4s work quite nicely.
Okay, great. Let me see here. I think there are more questions coming in. This is great. Let me see here. So this is both general and specific. What are Grodan's recommended start and end times for irrigation during flower? And how many feedings? I'm wondering if irrigation events
Yeah.
during that time.
So this is where I get to just go back to my slide that says data, data, data. The data is the only way you can make that decision well, because there isn't one prescriptive recipe. But so did you say the first part was how many feedings, and then it was start and stop time? Is that it, Greg?
Yeah, or vice versa. Start and stop.
Okay, so start and stop time is all you're doing there is you are adjusting that based on the overnight dryback that you want to achieve. So if you got a smaller dryback than you wanted to achieve the night before, you would typically push your stop time back so that you stop a little bit earlier, so that you achieve a larger cumulative overnight dryback. So that start and stop time is the input, but what drives it is the output that you're trying to achieve. If you don't have any data, this is where it becomes tricky. So, our long-term, very general recommendations have always been that, more generative steering involves, roughly 2 hours, stop time 2 hours before lights off, start time 1 to 2 hours after lights on. But unfortunately, that just doesn't cover the host of variables that you could have in terms of, rooting into a substrate early and needing a much earlier stop time, or having an over-rooted substrate and needing a later stop time to prevent a dryback that's too big. So without the root zone data, it's very, very difficult to nail the optimal start and stop time. But the general rule of thumb is 2 hours after lights on and before lights off is more generative, and 1 hour after lights on and 1 hour before lights off is going to be a more vegetative effect. As far as the number of feedings per day go, that is also going to need to be adjusted, usually daily, and it's determined by the inter-irrigation dryback you're trying to achieve. So in flower or generative steering, you'll be trying to achieve larger percentage drybacks between shots. In the vegetative phase, you'll be achieving smaller drybacks between shots. And so your frequency is really going to be dictated by your dryback percentage rate per hour on any given day. So that's where I wish there was just like a hard and fast, this many irrigations and this start and stop time, but truly it's going to be dictated by the feedback you see from root zone sensors.
Yep. Yep. The data, right?
Yeah.
Let's see here. There's a couple of good ones that just came in, and we may not get to all of them, but I will promise an answer, even if it needs to come by way of an email. I'll certainly connect with Marielle. If we don't get to answering your questions here during the webinar, you will be responded to. Let's see. I've got one here. Let's see. We've always used Hugos. Recently, we've tried 4-inch blocks sitting on top of the Hugos. It seems like the 4-inch block is sucked dry by the Hugo underneath it. Are we better off just using one cube instead of stacking media?
Sure. Yeah, this is such a good question. So what you're doing can be done and it can definitely be managed, but you're absolutely correct that when you start building substrate, well, so keep in mind, all of these blocks have fibers that are oriented vertically. So they are pretty free draining in the first place. And then when you start putting vertically oriented fibers on top of each other, you create a lot of suction pressure on the top block. So the ways to manage it, if you want to continue to run with that substrate volume, is especially when you're rooting into the secondary block, is to be really mindful of the water content in the top block. And typically the irrigation strategy has to be adapted for the first 72 to 96 hours of rooting into the second block. And the way you're adapting it is to essentially give very small shots, tiny shots, often 1% and 2% at a high frequency, just to encourage the water to continue to be held in the top block so that you can maintain a minimum volumetric water content of, at least 45 to 50% in that top block, so that the roots that you've built in that upper substrate don't die off and actually get to be sustained long enough to elongate and start colonizing and penetrating the block below and accessing water and nutrients from the block below. So a lot of people struggle with that configuration, is really just in the first 3 to 4 days of getting the roots to transition properly and not having any die off in that transition. Once the roots are established in the lower block, people typically have an easy time steering. But if you're asking me, broad strokes, do I suggest building substrate volume up vertically beyond, 8 or 10 inches? The answer is no. And I think you would be better off either building substrate volume out horizontally through using things like a unislab or our multi-plant slabs, or by, like you mentioned, growing in one larger single plant system block.
Mm-hmm. Great. I think this might be the last question we get to, but could you Marielle, talk a little bit about Grodan's eGrow monitoring system. Does that have all the sensors needed to monitor all the other climate data parameters?
Sure. Yeah. Everything that I mentioned, there's one exception. So all of the parameters that I mentioned via climate and root zone are accessible through the eGrow platform. So on the root zone sensor side, you can get water, volumetric water content, pore water EC, and substrate temperature. And I have to say they've just done an incredible job with the substrate specific algorithms and their accuracy in Stonewall products. So that's really great. And then on the climate side, the climate sensors that are accessible can show everything from ambient temperature, relative humidity, to CO2, and then it will calculate a room vapor pressure deficit just based on the ambient temperature and relative humidity. The one parameter that is not included in the climate sensor is light intensity. And so that is where a separate PAR meter would be needed to evaluate PPFD. And at this point, it's not included just because it drives up the hardware costs so dramatically. And so that's the one piece of, you would need some other way to monitor your micromoles per meter squared per second.
Great, thank you.
Yes.
As I promised, if there are questions, we will get you an answer. I'm not sure if I've covered them all, but I will review what we've been able to cover and answer. And anything else that we haven't, I will make sure that I consult with Marielle and we get you a response. So Marielle, if you could go to the final slide, I want to make sure we do our commercial here. So just for those of you that might need to know a little bit more about Griffin, we're certainly committed to this series. We're excited about this. There's been a phenomenal turnout, and I love all the questions that came through. Our CEA division, we're supported by 15 warehouses. We have a nationwide footprint. We have Grodan product in all 15 of them. We are independently owned and have been for the last 76 years. We certainly commit to providing reliable service. That's one of our trademarks. And by way of these types of webinars and our sales staff, we are certainly committed to focusing on collaborative success. Let's talk it through. Let's get you the answers that you need to grow your crop. There's our contact information. Reach out anytime. I really appreciate everyone's time here, and thank you for attending.
Thanks, Greg. Thanks, everyone.
Thank you, Marielle.